In this video, I'm going to talk to you about slope-intercept form of a linear equation. And there's a picture over here that I kind of want to talk about for a second. There is a parent function called y equals x, and you actually see that right here, y equals x. This is the parent function for linear applications, and this function is, we call it the parent function because it's kind of like the starting function, and then what we do from this starting parent function is kind of alter it. So if you notice, there's the function here, y equals x, and then this function that you see here, look at how it got altered a little bit. So instead of y equals 1x, now this function says y equals 2x, and so we altered the slope of this line here to be double what it was originally. So here is the function y equals 2x. And then again, from this parent function, altering your line, changing it, that means here would be a different function, so kind of altering it another way. This function is called y equals negative a half x plus 1. So you'll notice that the slope is now opposite direction. It's negative instead of positive 1. And it's half of what it used to be. And then not only that, we changed our intercept from being the origin to now up 1. And so this y equals x parent function is actually what our blank here. There is a linear parent function. And that's called y equals x, which we kind of talked about here, this red line that goes up. And then what we do is we change our function. We alter the slope, or we alter our y-intercept, like this graph here. And we get other linear equations, and that's what's going to go here. A linear equation is an equation that models a linear function, and meaning it's just a straight line. The variable of your function, y equals x, has to be a power that is no other power than the number 1. So here is a set of 4 questions here. Which of these would not be a linear function? And what you need to do is look at the power on your x. If we have negative 3x plus 4, the power here is 1, so this would work. Y equals 1x, the power on your x is 1, which would work. And then over here, y equals x divided by 5, or 1/5 times x minus 7. The power on your x is also still 1, which means the only one that wouldn't work would be y equals 5 to the x. And the reason why this would not be a linear function is because your x is in the exponent spot. And that means this function is actually exponential and not linear. Then here for letter C, the graphs of linear functions should always, not always, but many of them will cross the y-axis. There is one line that will not likely cross the y-axis, and that's going to be a vertical line. But generally, otherwise, your linear equations should cross the y-axis at some point. And then what you would see from your graph hitting the y-axis is a y-intercept. And that is going to be useful for your graph, and that y-intercept of the graph is the y-coordinate of a point that's actually going to be used in your equation. So y equals mx plus b, the y-intercept is the b of that function. So the first thing I'm going to have us do with the few examples below is identify what that point would be on the y-axis. So for each line in the graph below, all we're going to do is identify the y-intercept and write that point down on our paper. So the y-intercept here, we want to see the point that crosses the y-axis would be the point 0, negative 3. For the point on this graph that crosses the y-axis, you would see the ordered pair 0, 3. For this line over here, for letter C, you'll see the point 0, 5 is the ordered pair for where that line crosses the y-axis. And then we have 2 more. Maybe you want to pause the video and see if you can find the correct y-intercept. Here this point is 0, 0, and this last one over here is the point 0, negative 1. And in the next couple videos, you'll see what we're going to do with that y value for our function y equals mx plus b. that y-intercept is going to be this value of your linear function.